Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Jonathan Bennett joins me. We're going to be talking about the CNCF Community Infrastructure Lab, which is a place where you can test your open source software on real hardware. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Jonathan Bennett. Episode 452, recorded September 27th, 2017. CNCF Community Infrastructure Lab. It's time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randall Schwartz, Merlin at Stonehenge.com, bringing you each week the movers, the shakers, the big projects, little projects, projects you may be using every day and not aware of it, projects you may want to go check out right after this show. Today's probably one of those. Join me once again, Jonathan Bennett. Welcome back.
Hey, Randall, it's good to be here once again.
It looks like we're in the same two places that we almost always are. I'm in my bedroom in Beaverton, Oregon, and it looks like you're somewhere in Oklahoma.
Yes, the home office here in Lawton, Oklahoma, flyover country.
Right, which I'll actually be flying over on Saturday. I am heading out for my cruise, my 12-day cruise. So I'm looking forward to taking a tiny break from doing FLOSS Weekly, which is nice. But today, I'm definitely not taking a break. Today, I'm definitely doing a show, but I'm in Beaverton, Oregon, and we have a very interesting project on today. Let me find people's names here so I can actually say their names. We're going to be talking to a couple of people, one from the CNCF, which is the Cloud Native Computing Foundation, right? I have my Cloud Native Computing Foundation. And also we're talking to somebody from the Packet company. And what we're going to be talking about is the Cloud Native Computing Foundation's Community Infrastructure Lab. And according to their website, they'll be providing free access to state-of-the-art computing resources for open source developers working to advance cloud native computing. I think we just won buzzword bingo there. Okay, good. And we currently offer access to both x86 and ARM bare metal servers for software builds, continuous integration, scale testing, and demonstrations. We're going to be having Dan Cohn, I think that's the right pronunciation, from the CNCF, and Jacob Smith from Packet are going to be talking to us about this joint venture that they announced, I think, only about 6 or 7 weeks ago. So it's actually fairly new. I remember getting an announcement, and I had to be embargoed. And I said, well, I'm not really a news show, so it doesn't really matter. I'm not going to talk about this until it's way on anyway, so it doesn't make any difference. So what do you know about this so far, Jonathan?
I find it interesting that they use the term cloud native computing. That seems almost to be there seems to be a difference between cloud and native. I'm very curious as to what exactly they mean by that. You normally think of those as two opposite things. So I am looking forward to learning more about what they're trying to accomplish.
Well, let's instead of guessing about it or trying to read from the website, let's go ahead and bring these guys on. Dan Cohn, welcome to the show.
Hey, thanks so much, Randall. It's great to be here. I was involved in a project called the Core Infrastructure Initiative Best Practices Badge, and you had my colleague David Wheeler on, I think, earlier this year, and really enjoyed hearing that chat.
Very cool, very cool. And where are you speaking to us from?
I am in lovely Manhattan, New York City, and right on the edge of Tribeca.
I've been there many times. In fact, I'll be there in about 2 weeks. So I'll be in JFK for about all of 3 hours while I'm connecting over to go back home here. So that'll be great. So let's also bring on Jacob Smith. Jacob, welcome to the show.
Hey, Randall. Nice to meet you.
And where are you speaking to us from?
You'll notice from the latency that I'm not in New York City. I'm in Vermont, lovely Green Mountain state of Vermont. So there are at least 100, maybe 200 internet users here. For sure.
Okay, awesome. Let's start with Dan. Dan, why don't you give us sort of the big picture? What is this about?
Sure. So the Cloud Native Computing Foundation is a little bit less than 2 years old. We're part of the Linux Foundation. We're a nonprofit. We're best known for hosting Kubernetes, but we also have a lot of other projects like Prometheus, Containerd, and gRPC that all work well together. And we're really, our whole purpose of our foundation is to help open source projects thrive. And so part of that is that there's developers out there who have ideas that they're playing with on their own machine, and they want to figure out, is this going to work at scale or not? And so we partnered with Packet, and we're thrilled with the relationship we have with them. And they're making available $25,000 per month of credits that we then provide to open source developers. And so we give first choice of those resources to the 12 projects that we're hosting internally. And I can talk a little bit about some of the interesting ways we're using it. But I think the key message of this podcast is we are not using all of those credits yet. And so it is just a tragedy to let those go to waste. It's like empty airline seats. And so if you are a developer working on a project that you think could scale or should scale, or you want to test if it can or not, we would love to have you apply. It's a super easy process via GitHub. It takes a couple days for us to set you up with an account, and you can be working with some of the most amazing state-of-the-art machines, and also some really cool sort of edge, different configurations that Jacob can tell you about.
Yeah, I want to back up just a second, though, because one of the things I saw at the Open Source Summit, I think it was like 2 weeks ago. Well, my life is a blur, so I have no idea when these conferences are anymore. It was 2 weeks ago. It was this huge, like 80 logos, and they said this is all part of the CNCF. And so describe a little more about what the CNCF is. It's a consortium of industry.
Yeah, and that slide that you saw was definitely out of date because we're up to like 130 or something members at this point. And so you can think of us as a software foundation, a lot like Apache Software Foundation or OpenStack. We're sort of the youngest one, and our aspiration is that we, by coming later, are trying to look at some of the mistakes that other foundations have made, and we want to go make entirely different mistakes. And so we've so far been really successful in bringing together this now 12 really amazing projects that have all agreed to be hosted by CNCF. And we have a pretty extraordinary group of members. We've also just had a really amazing fall where we've just signed 6 new platinum members in the last 2 months. So Amazon, Microsoft, Oracle, Pivotal, VMware, and in fact, today in the next few minutes, we're going to be announcing SAP as a platinum member. And so one way of thinking about what we're doing is that all those members are coming together, all those companies, because they care about investing in this open source software stack that gives users options, avoids lock-in, allows you to move between public, private, and hybrid clouds. And this community infrastructure lab is one of the ways that we can use their resources and help direct them in order to help move the industry forward.
Awesome. So let's hear from Jacob here. So Packet is a service provider?
Yeah. So we're about 3-year-old company. So we're almost we're a little older than the CNCF, right? We're a cloud essentially. So we're pretty similar to what you might find with an AWS or Google Cloud or an Azure, except for kind of one major difference, which instead of offering sort of multi-tenant virtualization-based cloud computing, we offer dedicated servers, nothing more than that, right? And so that's where our alignment with cloud native, which is that buzzword we were talking about before, is really exciting for us because software is getting really good at moving stuff around. And it doesn't necessarily care all the time if it's working on a VM or working on a bare metal server in a private cloud, a public cloud. And so it's a really good fit with Packet, which offers bare metal servers instead of VMs. And
so, actually, I want to ask Jonathan's question from this morning, or from this morning. It's all been this morning. Come on, from just a few minutes ago, which is. So, what does it mean, cloud native? I don't quite get what that is.
No, we should have a runoff.
Right.
Okay.
We've thought of relatively offensive logos that we could do that include clouds and natives. But the idea is that it's a new form of computing that really the most important trend of the previous decade was virtualization, virtual machines. And the biggest winner in that by far was VMware, where all sorts of companies run their servers because they used to often many applications only take a few percentage of the total capacity of the server. You put the application in a virtual machine, and then you can stack tons of VMs in a single server. But we think the biggest trend of this decade is containerization. And so the idea of cloud native is that you take your application, you break it up into different pieces So from a monolith to what we call microservices, you containerize each of those separate parts of your application, and then you need an orchestration system in order to make sure that all those different parts of the containers are running and that they're allocated correctly and packed in. So we define cloud native as those three words: microservices, containerization, and orchestration. And Kubernetes has now emerged as really the leading part of software to enable that, but there's a lot of other complementary projects that CNCF hosts and other organizations host, or that live on in GitHub, that are all working together and make cloud native computing feasible.
So is this something that would be described by, say, the 12-factor app? Is that kind of in that ballpark?
It's a great question. Interestingly, 12-factor app, which Heroku created back in 2009, was, I think, a critical first step in what we think of as kind of the DevOps revolution. And that sort of general area, which is often described as PaaS, platform as a service. PaaS runs incredibly well on top of cloud native, but part of the idea, and so if you can make some of your microservices 12-factor, that's great. They scale better, they work well together, etc. But part of the idea for Kubernetes and cloud native is that some of your services actually need to keep state. Or if you think about it in Heroku and 12-factor terms, yes, some of your applications are running 12-factor, but they also are talking to database, to say Postgres, to Redis, to other kinds of services, and you'd love to have those running on top of the same infrastructure. And so Kubernetes aspiration is to be great for running 12-factor, but also able to run older monolithic applications and stateful applications and other types as well.
So can I offer a different opinion, or at least a different version of it?
Go right ahead.
So everything that Dan said is correct. But from a marketing standpoint, a buzzword, I like to think of cloud native as sort of like VMware for millennials. It's sort of like, you don't own a house anymore, you have an apartment, you don't own a car, you get an Uber. Well, cloud native is like super portable, cattle not pets, destroy it, get another one. Sort of you came of age during the cloud when you could go to Amazon or anywhere else and get a VM, right? And then just destroy it, or you get 100 of them and then just destroy it. And part of that sort of mindset, the cloud native mindset, I think, is as important as anything in the technology stack, which is that you bring your own software, you're deploying everywhere, it's all. And that's cloud native from a consumption experience, right? And so you're just kind of at your MacBook Pro deploying your world dominating SaaS platform.
So the lab that's set up, is it limited to running things inside of Kubernetes, or is it more open to other solutions?
Definitely not. So we're thrilled for you to reuse any orchestration solution you want. Our requirement is just that the software that you run on it, we want it to be open source. And so this is where I make my Bitcoin mining joke that we're trying not just to make and in fact, the joke's like years obsolete, because you can't compete with Bitcoin mining today without ASICs. But the requirement is that we want you to use at least one of those aspects of cloud native. So if it has anything to do with microservices or containerization or orchestration, then you're very welcome to apply and get the resources.
What if we're working on a cloud-based open source Bitcoin miner? Can we test it there?
We know this guy. We know this guy.
Yeah, we know this guy. So how did this come about? How did Packet and the Cloud Native Computer Foundation, how did they come together, and what was kind of the impetus behind making this work and opening it up to the larger open source world?
Cool. I can probably answer that, Dan. So, Jonathan, it's funny. Dan's based in New York City, and so are we. Even though I'm in Vermont right now, we're a New York company. And we were actually having coffee, and we had come to Dan because as a company, we sort of came of age at the same time that I'd say cloud native was just starting to take the world by storm, whether it's Docker or Kubernetes. This was, like Dan said, the trend of the next 10 years. And so we've always been really interested in that. We see that as sort of like our next consumer, if not our current consumer. And so investing and partnering in something like CNCF is just really natural for us, because that's that's we see a lot of value both for Packet, but really mainly for our users. Okay, so we were having coffee in New York City, and we were just like, is there any way that we could be more helpful with that, especially when it comes to things like, testing low-level systems, innovating below the hypervisor, getting your hands into some new hardware, maybe even playing with a different architecture like ARM versus Intel. This kind of stuff is a little hard to get your hands on. And as most developers these days, especially what we would call cloud native developers, they don't have a lot of servers in their basement, let alone access to colo, right? And so, we thought, hey, this would be a great chance for us. We were expanding. We've got, a really dynamic platform where you can deploy in 8 minutes and tear it down. It's all automated. That we could say, hey, why don't we open the doors for this? And this was a good way for us to kind of focus our investment in cloud native. And of course, the CNCF is really the place to be. Right.
So is sorry, that caught me off guard. So what kind of applications are you looking for? What kind of projects? So we joked a little bit about not wanting Bitcoin miners on the network. Is there any other guidelines that you kind of have in mind of what the kind of projects that you want to show up and the kind that you really don't?
I definitely would do it more as the negative that we want it to be open source, and so we'd like you to have at least some plan on, hey, here's the thing I'm working on, here's how it's working today on my own Linux machine or Mac. When I can scale it up to a dozen or 50 or more servers, these are the things I'm hoping to learn, and then I'm going to contribute that back. But that's just an aspiration. In fact, I'd really just say that we're incredibly open to the opportunities for folks who'd like to get involved, and we definitely have much more of a, we'd rather give you the resources and then complain if you're not using them well or in an interesting way or using them, than to try and do some sort of really careful quality control on the front end.
So this has only been around for it's been around for a short period of time. I think it was something like six weeks ago, somewhere in there, you announced this. What kinds of projects have started showing up at your door?
Yeah, so I have two that are kind of interesting. So the first one is that we have a project called CoreDNS, which is so one of the 12 projects that is now using these packet resources as part of their regular continuous integration. And so just every time somebody makes a commit on the CoreDNS repo, it now moves over, and they have some relatively unique requirements that they couldn't just use Circle CI or Travis CI like a lot of other projects, including our projects, do. Actually, two more. Another one that I think is pretty cool is that we've built a real-time dashboard for the Kubernetes leadership. It's available to anyone, but it lets you look at every commit that's been made to all of the Kubernetes repos, every issue that was filed, how long it took to get assigned to a special interest group, how long it took to get a review, time to close, average 15th and 85th percentile, all of these details that they're using to try and better understand their project and figure out how they can better allocate resources. Because Kubernetes is definitely struggling under just insane, enormous growth. It is, based on how you measure, something like the fourth highest velocity open source project in history. It has over 1,800 unique contributors over the last 12 months. And what's kind of cool about this project is that an earlier iteration of it was just fetching the data from GitHub, but that doesn't give you the historical data you want. And so instead, we're using this free resource called GitHub Archives, where literally every action that you do on GitHub with a public repo, starring it, making an issue, making a commit, is all recorded and then made available in JSON format. And we're using this massive 24-way server that Packet makes available, and some custom Go programming that we wrote to fetch in these archives. And then we go through it and throw out everything that's not Kubernetes, because GitHub makes the entire archive available for all 65 million of their repos, we only care about 80 of them. But
Wow.
Amazingly, we can process everything in the previous 3 hours. Then we load it all into a Postgres database. Then we analyze that, and we're converting it to time series in an InfluxDB database. And then we throw it up on a Grafana front end. And we can include the link in the show notes. It's still very much under development, but it's called CNCF-test.io. And it's really just an amazing thing to have those resources that we can process all of those repos going back in 3 years in under 2 hours.
Wow. And so what does $25,000 worth of server time look like? Is that 10 machines, 100 machines, 1,000 machines? I'm trying to get the right order of magnitude here.
Yeah, I can help with that. So first of all, we thought about doing $1 million a month, but it just didn't sound as good.
You have to twist your finger by your lip when you say it.
Exactly.
Right.
And there's luckily not like a big battle axe that comes down when if we're really successful with this, we'd like to see it grow. For us, that's an investment in the community. But what does $25,000 look like? In the case of, like Dan was mentioning, a big old honkin' server that processes 3 years of GitHub data, in 2 hours. You could take about 25 of those servers and run them nonstop all month, and that would be $25,000. It's serious infrastructure, right? So it's big boy stuff. But a lot of the projects are also able to take advantage of smaller bite sizes that we have. Now, they're all dedicated servers, but we've got servers ranging from 5 cents an hour to $1.75 an hour. So you basically see a lot of up and down and variety of usage when someone wants to, say, do scale testing, or a good example might be CoreDNS wants to go and deploy in all 15 locations to test geo-routing of their, failover DNS feature that they're trying to do. So I think that, keeping that in mind, you get a lot of up and down. $25,000 is a pretty good amount of resource for this kind of use.
Now, what's this like for me to apply? What is there a lot of paperwork involved? And also, do I have to be a member of one of these 150 organizations?
Yeah, I really appreciate you asking both of those things, because the answer is it's incredibly easy. It's like 10 or 15 minutes of work to apply. And you absolutely do not need to be a member of any of our 125 members or of even an active contributor to any of our projects. You absolutely can just be a random person on the internet with an interesting project that you want to try out. And so you go to cncf.io. Under Community tab, you choose Infrastructure Lab, and at the bottom of that is a link to open a new issue on our GitHub for it. And we have a little issue template that just says, okay, what's the URL of the open source software you're going to be deploying there? What are you trying to learn from it? A few other things. And the probably the hardest requirement is that at the end of it, we'd really like you to write up a blog post describing your experiences. But at the end of the day, we're not going to hound you at all hours and day and night to get you to write the blog post. And hopefully you have a project and some work that you're excited about, and you'd like to promote it to the people who are following CNCF, that we have a pretty actively followed blog.
And so what's it like spinning this up? I'm familiar with spinning up like an EC2 instance. Does it sort of look like that?
It really does. So once we give you the resources, I'll give it to Jacob, but the magic here is being able to provision bare metal in 8 minutes is really a pretty unique experience.
Yeah, so it looks and feels and smells a lot like deploying EC2 on Amazon or GCE or whatever it is, So you deploy, you can either use the API directly or log in through our portal, or you can use something like a lot of our users are using Terraform or Ansible, and you can just use the supported providers there. So it feels like deploying a VM, and our best compliment usually, when we're looking for them is, hey, that's the fastest VM I ever tried. So,
and I'll make that pitch, is it feels like a VM, but without the noisy neighbor problem. So once it's running, that machine is dedicated totally to you.
Yeah. So I wanted to jump in and ask, what do the edge cases look like on this? And I'll give you a little context about what I'm getting at. One of the open source projects that I'm looking at and working with is single packet authorization. The project is FWNOP. It's also known as the software defined perimeter, all kind of the same concept, same ball of wax. And one of the things we do a lot with that is direct access to the firewall to be able to allow and disallow different packets from different sources, but also using PCAP to be able to get incoming packets. So if we were to apply to using the lab, is it even possible for us to get low-level enough access to the machines to be able to start working on that? Or because we don't yet have, at least in the projects I'm working with, we don't yet have really good ways to tie into containers. So does it work for real cases where you need real bare metal like that, or is that kind of an edge case that's difficult?
I would suggest, and Dan can give his opinion as well, but that's one of the neat aspects of this as cloud native kind of goes to scale, right? That you start running into serious networking security issues. These are all active things. And, containerization is, one of the main trends, but it's, that's just a part of the solution, right? And so something that you do get at Packet, which I think is the really interesting part for software developers and projects like yours, is that you can actually touch. You define your own firewall here. You can touch the network cards. We'll tell you exactly what they are. You can use the full suite in there. There's no sort of layer between you and the hardware. You get the hardware, all right? So if you want to do hardware tuning or, do custom things against your fancy Mellanox NICs that we have in the servers, or play with BGP or other sorts of kind of what you might call sort of carrier grade features that would normally come in a dedicated environment. That's exactly what Packet can allow you to do. Now, not all software developers are trying to do that. Sometimes they're just trying to test software at scale, but we do see a real space for innovation there where people are coming in and saying like, ooh, I'd really like to go touch that part of the stack. I think I can innovate on that. And this is a really great resource for that. So I'll let Dan answer whether or not you're allowed to apply. You might have to talk real sweet,
Oh no, we're thrilled to have you. And so, I think a key part of this lab that we're really excited to talk about is the fact that most people today are running containers on top of VMs, and so they think of it as all of these layers of abstraction between them and the hardware. But that absolutely does not need to be the case. And there's really great examples today, for example, people using Kubernetes, that you can allocate out certain nodes and say, okay, this server has this kind of GPU attached, and then you can tag your containers and say, okay, these containers need to have this level of resource from a GPU, and Kubernetes will automatically schedule that for you. And so, and then your hardware, your application can reach through the container and make take advantage of whatever the capabilities of that underlying server are. And so we'd absolutely love to see people playing with similar things, for example, that are available in the network card or in the exact kind of chip that's being used, that we really would like to see people pushing the boundaries.
Yeah, and I would add to that one last.
Go ahead, Jacob.
We are seeing a lot of, as software gets so smart and so dynamic, right? Kubernetes is an amazingly complex and capable system that it's able to touch a lot more parts, be more complex, honestly, than if you think of in a more IT-focused world where the people had to make the choices. Here, Kubernetes can really sniff a lot of that out. If you tag it and define logic, it can start to understand all the complexity down there. So I think what we're seeing in cloud native now is also, a bunch of new hardware manufacturers as silicon sort of moves to the network offloads. And we have companies like Mellanox or ARM or, Intel, of course, developing all kinds of new silicon and features on the hardware level that really are well suited to cloud native, because cloud native can really take advantage of that,
So how do you recover from letting users touch the bare metal? I'm trying to imagine how someone can set up a new instance, which is actually bare metal, so a server, and then let that instance go. And so you guys would then have to kind of automatically clean it up and scrub the disks. How does all of that work?
Great. That's a great question. I'm glad you asked it, because you've obviously touched a server before. You should not trust it when someone gives it to you. So our sort of expertise and what we do really well, our technology, frankly, is around life cycling of hardware. So deploying a server with your operating system and getting the network working is complex, but it's not rocket scientist, stuff. But one of the things that kind of is more complex and really important is deprovisioning. It takes about 3 times as long as actually provisioning, because of course we have to wipe the disks. That's the simple part. But checking things like firmware, people flash the BIOS, this kind of stuff is not But this is real life stuff. I mean, if you think that your server is protected just because there's a man trap and a retina scanner at the data center, that's a bad idea. And so we're actually really interested in that kind of process. It's not something that most of our customers think of out of the box. But when we see cloud native driving workloads, say, towards the edge or to lots of places, maybe because of regulation or performance or other things, you can't trust that hardware. That's not, you need to make it trusted. So there's a lot of technology going on in the cloud native space to help understand that hardware. And we do our part by sort of on the back end. When you give us back a server, we don't trust that you've left it the way you got it.
Mm-hmm. So Jacob, or possibly Dan, but probably Jacob, let me ask you this. Are there some open source projects to do that sort of thing? So the firmware validation is what I'm thinking of. We see these persistent threats where someone can, flash malicious firmware onto a video card, let's say. I guess first off, are there any open source projects that let you go in and check that? And then some of the technology that it sounds like Packet has developed. Have you or are you looking at pushing that out as open source projects to allow other people to use it?
Yeah, that's a great question. Yeah, we are considering that. Right now it's not open source. And there are some examples of the, I would just call them major clouds where they're doing innovation. I think you saw Google come out with a pretty strong sort of hardware security chip, which sort of trusted compute style thing, which helps to give a level of trust on the stack. But no, I don't think there's a lot of great stuff out there, mainly because the hardware world has been involved in sort of shipping boxes for a long time and not really operating them. We're seeing now, as software kind of works its way down, a lot more touching at hardware and also just a lot of exploits, right? Where it's like, oh, my software's up to date, but that firmware version was wrong, or someone actually did something quite malicious there. So we're considering how to open source what we've done. It's a really intriguing thing for us right now. We're working with our vendors, which are Dell, Supermicro, Quanta, the custom manufacturers, and trying to just get some level of standardization around how we even deal with that kind of stuff. Because the back end of hardware is pretty unrefined.
So some of the groups that I am involved in, one of the things that gets talked about is whether or not you can even trust the different trusted platform bits. So I think of Intel has their management engine built into all of their new server chips, and there were some open source communities where people were sharpening the knives and bringing out the pitchforks, saying we've got to be able to turn this off, or essentially we can't really trust this computer. And then I found it interesting. Back a few weeks ago, I saw that apparently the NSA had the exact same concern, but because it was the NSA, they were able to tell Intel, you need to give us a way to turn this off. And finally, that bit leaked out, which I thought was really interesting.
I think you're tapping onto a really important thing here. I mean, there are some really great projects like TPM, Trusted Compute, but it's all about the whole stack. So you see like CoreOS and their Kubernetes distribution has a TPM sort of Trusted Compute component, which only works, of course, if your server has a TPM chip, which ours do. But that being said, I think you're going to see a lot of different answers to the security question. One of the great examples for us, and one of the reasons why we have ARM systems in our platform, is because of the sort of experience the ARM ecosystem has in untrusted devices. I mean, we all have them in our pockets all the time, and sort of there's a lot of interest for us as we see the sort of hardware integration, software integration ecosystem develop, is how security works, especially as you are being really dynamic with workload and trying to take advantage of that GPU over there in the corner, with your container.
I think you just stole my next question, though, which is, I understand x86. I understand that that's the main computing platform around, but why ARM? What's going on with that? Are there people doing high volume deploys with ARM?
I think the hyperscalers are all playing with ARM, right? So just full disclosure, we have investment from a company called SoftBank, and after we got investment from SoftBank, they bought ARM. So there's some natural collaboration there that we've done.
Yeah.
Let me give it from my side, which is within Kubernetes and with some of our other projects, there's a huge level of interest in ARM. And so obviously there's billions of ARM chips out there in every iPhone and Android phone and such. But ARM on the server is incredibly intriguing. Maybe not for every possible workload, but it certainly looks like there's a lot of workloads where it can provide much better cost and particularly power efficiency. And so Kubernetes is actively developed on it. A bunch of the like Brendan Burns, who's one of the co-creators of it, has a little Raspberry Pi cluster in his garage that he plays with. And essentially this packet resource is saying that you could scale that up to a significantly higher level and that you don't need to actually be configuring your own Raspberry Pi cluster in order to get to play with this.
That would be fun. That would be fun, though. Well, that's actually another question I had, which is, can I use auto scaling? And how do I throw a test load at it to make sure that I can get the auto scale to happen?
Well, so you click there and press the spacebar a lot, right?
I'm not a test monkey. I'm not doing that. I'm not a scratch monkey either. Okay.
I got this all wrong. No, obviously, auto scaling is just dependent on automation, right? So what most of our customers, like at any other place, they have a worker that generates workload and they push it at something that then says, hey, when this gets too much, start to generate me more nodes. Go get me more resources. And that works at Packet just like it does at, just at AWS. It does take, 6 to 8 minutes instead of maybe 2 to 4 minutes. So there's an implication there, but that's just math.
Okay. And so go ahead.
Sorry, I was just going to say, a lot of people are using Terraform right now as a standard mechanism piece of software to avoid having to write custom to every provider's API. And so just like there's Terraform modules for AWS and GCE and Azure and all the others, there are for Packet as well. And in fact, I can tell you about a project we have that's using those right now.
And what does this look like? Again, I mean, I'm trying to figure out. I'm not hearing any boundaries about like how many CPUs I could use, or how. I mean, is it all just a matter of me justifying building something with this that's going to be open source?
Yeah. So Jacob, if I want to spin up all $25,000 in 1 hour on ARM servers, what's that number? But it's a lot. I don't know that you can actually provision that many servers for us all at the same moment.
We could provision them, but we would run out at the moment. I mean, see, here's the problem with physical hardware is that you can't cram more people into the same. You can't oversubscribe it, right? And so there is, a different kind of capacity. What we've introduced, similar to Amazon has a spot market, right? So we just introduced this summer sort of the first spot market for bare metal, where what we do is we allow our community to buy basically super cheap resource with the, contract that we can take it back when we need it. So we're actively developing that sort of pool of allows us to overinvest in having more ARM servers around. So when Dan wants, 1,000 of them for an hour, and he's willing to pay for them, we can revoke them from people who are paying a fraction of the cost. So that's interesting. But I think, to your point, though, you're asking more like, why aren't you talking about all the restrictions? And I think that's just kind of the spirit of open source, right? And I don't mean to overdo that, but that's really a powerful movement, right? A powerful movement of saying, like, look, to move this stuff forward is good for all of us. That's why you see companies like, Oracle and SAP sitting in the same room as Google, right? At the CNCF. Is because this is a beneficial, to helping more people get more out of their infrastructure and use more of it and do more great things. And that's a little bit, naive sounding. But what we've done here is put a pretty loose set of requirements that says like, hey, let's try to utilize $25,000 of stuff to move these projects forward, and honestly to invite the community in to take advantage of a resource that, frankly, it's pretty hard to get. It's not hard to get cloud computing. It is hard to get dedicated servers, right? It goes back to like, hey, how long do you want to sign a contract for? You get it for a month. We'll give it for $200. That's not really going to be useful for these kinds of projects. And so what we're trying to offer, and I think that we're in a unique position to do it, is like, no, come and give us your ideas. And let's see how to say yes to that, because we think Packet, and I know CNCF believes it as well, that we're helping to chart the course, for the next VMware, right? So cloud native is sort of the wave that we're all trying to encourage to roll.
And going back to the test load thing again, how much bandwidth can I get to these machines? Are you pretty well stocked there?
So our name is Packet, right? So we do
you have a lot of little packets somewhere.
a lot of packets. And that's a great question. So one thing about our network that is kind of different than most networks at a public cloud basis is that we use what's called a layer 3 topology. And so there's no sort of shared top of rack VLAN, right? Where you're kind of, it's the same thing on the server. You're not sharing it, right? And so each server is connected to a top of rack switch. And basically you can get line rate to whatever the NIC cards are on each server. So an example, the big boy server that Dan was using to process all of GitHub's archive, that has two 10 gig ports, Mellanox Connect X4s, right? These are serious. And that's what, you see in Azure and other places. They're just using them behind the scenes, and you're getting sort of your allotment of that. At Packet, you can go and actually push close to 20 gigs a second, which is basically break the internet sort of traffic. So obviously, we do a fair amount of fraud and abuse review on any account that gets into our system because, that's a really attractive proposition for people doing bad stuff. But on the other side, this is the kind of throughput that some of our projects that are, say, you see telecoms getting into the cloud native space, and you see, satellite companies and people using it to do all kinds of high performance scaling things. A big part of that is usually the network, right? And at a public cloud at the moment, sort of network is that one thing you have to buy that you really don't have a choice over. You have to buy the network. And yet you get pretty limited access to understanding how that works. So I think that's a really neat part, and I'm really excited, especially with projects like CoreDNS, but also, other ones that are dealing with global, traffic management. Scale-proven, technologies like BGP, that doesn't exist in the public cloud by and large, right? You just can't get that. But that's a really proven, carrier-grade approach to how to route and manage traffic. And that's something that we can give access to that I think answers part of your question. Is you could push a lot of bits, and, Packet owns its own backbone and network, and it's global and it's all that good stuff, right?
Cool. And I think you might have answered this already, but can I also ask for a machine that could feed another machine, could actually be my test load for it? Or do I need to provide that on my premises?
No, go ahead and just get another machine. Cattle, not pets, right? So go ahead and grab, we have a pretty simple nomenclature, type 0, 1, 2, 3. These are our basically extra small, medium, large, and storage. And what most developers do is they'll go grab the smallest instance, the little EC2 or at Packet at type 0, which is a small little Intel-based, 5 cents an hour dedicated server, and literally half the cost of an equivalent VM. It's kind of cool. And they'll use that to generate workload or to put their bits on they want to store. And then they'll go spin up different sizes. And that's where something like Dan said, Terraform. Terraform is so elegant in saying like, oh, get me some of these sizes and then go get me some more if we run out. And, you just get another server. So you don't have to bring your own servers. You just have to bring your own software.
That's awesome. Well, we're almost out of time. Is there anything we haven't asked that you want to make sure our audience is aware of before we have to let you go?
I'd just love to pitch you on one other project that's using this resource right now that we think is pretty cool. That we're developing inside of CNCF. It's called CrossCloud, and you can see it on GitHub right now, CNCF/CrossCloud. And what it's doing, it's eventually going to get all 12 of our projects. Right now, it's only working with 3 or 4 of them. But it actually takes the latest build of Kubernetes, of Prometheus, of CoreDNS. It'll soon be adding FluentD and others. And then it using Terraform, it spins up separate clusters on each of AWS, Azure, Google Container Engine, Google Cloud Engine, and certainly Packet, and deploys all of that software onto all of those clouds. And so each of our 12 projects has their own continuous integration system, and we're not trying to take it over from them, but we're pretty excited to be building out this cross project or inter-project continuous integration to show that this stack does work well together and work on each of these different cloud configurations. Cool.
And Jacob, anything, last words from you?
No, I think that this is a great year for the CNCF. I mean, amazing growth. I mean, I just don't know how Dan's hand keeps, fluid with all those platinum members. But one thing I if I predict the future, what we're seeing is, the enterprise has, gotten behind cloud native, and maybe that means Kubernetes. It means a lot of things, microservices, the whole approach. But we're starting to see a lot of that come in. And in that sense, then people are saying, hey, can I deploy this whole stack on something that looks like my data center? Because I'm going to keep something in my data center or whatever. And that's where this cross-cloud initiative and other things is really fulfilling the promise of cloud native. You can deploy it anywhere you can deploy software, and that's the whole point of it.
Oh, and I'm sorry, guys. I just have one other thing I forgot, which is that tomorrow I'm very pleased to announce that we're going to be releasing the schedule for our biggest conference of the year, KubeCon Cloud Native Con in Austin, December 6th through 8th. And we're going to have over 3,000 people there, all of these vendors, just an amazing lineup of talkers that still really run as a community conference where we have just an amazing group of keynoters and presentations. And so we'd love to have your listeners take a look and consider it. We also have a diversity scholarship that's available for several dozen folks that the deadline hasn't passed out on. And so folks should also take a look at that if their company can't send them.
And I know I'm going to put you on the spot now, but do you have a discount code for our audience?
That's a great question, and I'm going to be happy to talk about it in the show notes because we love you.
Sure.
And you're a great target for this.
Good.
And
good.
We'd also love to get you to come and do some simulcasting from the event.
That'd be cool too. I'll have to look at my schedule. My schedule's my schedule's my schedule. It's just crazy. It's just all over the place.
You're going on a cruise. You're going on a cruise.
I'm on a cruise. I know, but that was the last second. Come on, it was like crazy. So anyway, Dan and Jacob, great having you on. Great project, good cooperation between the two of you guys, and all of your representative organizations, of course. But thank you for telling us about joining the lab. That sounds really cool.
Yeah, we love your show, and so thanks so much for taking the time to hear about what we're doing.
Awesome. That was Dan Cohn and Jacob Smith talking about the new infrastructure lab. What do you think there, Jonathan?
I think we're going to get lots of hate mail because we didn't ask them about their favorite programming language and their favorite text editor.
No, maybe that's okay. It's okay. I can leave that out every once in a while. I'm not going to get that much hate mail. But anyway, so yeah, this sounds like a really interesting project and a really good use of shared resources. I mean, it's a great way for Packet to get their name out there, so we'll start thinking about using them instead of AWS or whatever. It's also a great way for the CNCF to get some resources to really work intensely on these projects, because sometimes you do need big metal and stuff to actually test things out. So anything else before I start talking about the upcoming guests?
Sure. It is interesting. There's a lot of open source projects, that, especially ones that are kind of just getting started and just exploring some new ideas. And sometimes to see if that's ever going to work, you've got to have these big installations. And it can be a big problem to try to get that much, whether it's CPU time or network access or, maybe even that much RAM all at once to be able to work on whatever it is. And so I think it's really interesting that there's somebody out there that's trying to meet this need, saying, look, we're interested in the things that you're going to come up with, and let us help you, come up with those things that you can help all of us. And then the other thing that I found really, really, really fascinating was the work Packet is doing with trying to go in and what's the term he used? Deprovision these servers that random strangers from the internet have been able to use. I mean, that's terrifying. If you really understand some of the security aspects of it, it's a scary thing. And I think it's really, really interesting that they've, apparently solved, or at least trying to solve some of these problems. So I do hope that they can open source some of their toolkit. And if they do, we'll try to bring them back on and talk to them about it, because that's really fascinating stuff.
Sure, definitely. So yeah, I think it's fascinating too that we've gone now 360 degrees around. We've gone, you bought a dedicated machine 20 years ago, you VM'd everything 5 years ago, then it was all containers 2 or 3 years ago, and now we're back to dedicated machines running containers. So it's like a Lego set just being constantly built up. Really, really cool. So that's really good. Yeah, it was fun bringing these guys on and talking about that. So let's see who is coming up next week. I am not going to be here. I will be having Aaron Newcomb's going to be the host. Don't quite know who the co-host is going to be yet, but we're going to be talking about Live Git 2, which is an embeddable Git core. Following week is openbenchmarking.org. You want to talk about that, since I think you brought them to us?
Yes. So that's Michael Larrabell. He runs the Phoronix.com website, but he also does Phoronix Test Suite and Open Benchmarking. And his focus is really about being able to do reproducible benchmarks on mainly Linux machines, although I think he does some BSD and Windows as well. But he also is kind of one of the guys that keeps his fingers on the pulse of the Linux desktop and the news going on there. So that should be a really sort of a wide-reaching and broad show, but there's quite a few things I'm looking forward to learning about that.
And you're co-hosting on that one. But we also have Dan Lynch is going to be hosting that one, so it'll be his first time in the big chair in a few years. That'll be nice because, again, I'm going to be on a cruise for a couple of weeks. Following that, we'll have Project Flogo, which is IoT integration for devices. A nice small stack. Instead of having something as big as Node.js to be able to run IoT stuff, it's going to be a tiny small stack to get right at the hardware. Bedrock, which is a distributed database built on SQLite. The JFrog Artifactory, which is a repo manager for binary artifacts. Crail, which is high-performance storage networking. OffNet, which I found very fascinating. They're providing Wi-Fi hotspots for local content in Zimbabwe. So actually, we'll be speaking to our first guest from Zimbabwe, and he says he's going to have bandwidth because he works for an ISP. So hopefully he won't have Skype problems. Hopefully there won't be any Skype problems. He says we got bandwidth. So here we go. And just added to the schedule between last week and this week is Linkerd, which is a transparent proxy that adds service discovery, routing, and failovers. Right after that, we have Crail, which is high performance storage networking, and OffNet, which is providing Wi-Fi hotspots with local content in Zimbabwe, of all places. That's going to be really cool to talk to somebody in Zimbabwe. And just added to the schedule between last week and this week is Linkerd, a transparent proxy that adds service discovery, routing, and failovers. And I think I just talked to them at the Open Source Summit, and now they're on the schedule already, but they're not out there until way out in December. But we'll have them. If you go to the homepage for this show, twit.tv/floss, you can see the big spreadsheet linked from there. If you have any other suggestions, please tell the project leader or community coordinator to email me, merlin@stonehenge.com, and I'll get them on the show as quickly as I can. We have a live stream, 9:30 a.m. Pacific time on Wednesdays when we tape this show. You can follow us at Floss Weekly on Google Plus, and also at Floss Weekly on Twitter. You can follow me at Randall L. Schwartz on Google Plus, and that tweets over to at Merlin, M-E-R-L-Y-N on Twitter. I'm going to be in the Adriatic Sea for the next 2 weeks, so you won't be seeing me around. It's going to be my 81st cruise, and after this cruise, I will have 652 sea days. So I'm definitely a sailor at that point, I guess. All right. And then I'm going to be at the allthingsopen.org conference coming up in about 3 or 4 weeks. We had them on a couple months ago to talk about what that is. And then I'm going to be at another cruise through the Panama Canal in January. So I've got cruises coming up. It's going to be so fun. Anything you want to plug there, Jonathan?
Oh, I'll just say that you can follow me on Twitter at JP_Bennett, and I am not taking a cruise anytime soon, but I am doing construction work on a house. So one of these days we'll move home offices. Looking forward to that.
Nice. Well, let's see, slightly different background, maybe. That'll be cool.
Yes.
All right. Well, you won't be seeing a new background from me for another few weeks, but I'll be back on here. I think my next show is here again. If not, I'm going to be at the All Things Open org conference. Maybe it's going to be down there instead. Anyway, that's enough. So, Jonathan, thank you once again for being my co-host, and always glad to have you on. And we'll see you all again next week on Floss Weekly.